In this example, we are looking to find the equation of a tangent line to this curve at this point of 3, 2. So in the past, we're going to be using this line or this equation right here, the point slope formula, and we have our coordinate that we're going to sub in. We just need to do the calc to figure out the slope. So us doing the slope is us finding the slope equation, which is us doing the derivative of this. So in general, though, let's take a look at what this equation looks like. So let me switch my screen. All right, so there is our graph. And I don't know, looks like that. So it's not a function, but it's something that Desmos can handle. We're going to be trying to figure out what the tangent line is this. So if I just look at it, I know I'm going to get a positive slope of some kind, just to keep that in the back of my mind as I go through it. And then we're going to throw in our equation and see if it does what it's supposed to do. All right, so let's go back. All right, so here is our equation. We need to do the derivative of this. So the derivative of this with respect to x is x squared plus xy minus y cubed equals 7. Right, so us doing the derivative of this is derivative of x squared is 2x plus, this is a product rule, so we're going to be doing the derivative of xy. So the derivative of x is 1 times y. So the derivative of the first times the second plus the first times the derivative of the second. So that's 1 dy dx. Don't forget that if you're doing the derivative with anything other than x, you're going to have that extra fraction onto it. Minus, you'll have it here as well. So minus 3y squared dy dx equals derivative of 7 is 0. Right, so we're looking to figure out what the slope equation is, so then I can go ahead and plug in my x and y coordinate. So let's do a little manipulation. So let's solve for dy dx. All right, so to do that, I'm going to leave the dy dx's on one side. I'm going to take anything that doesn't have a dy dx and move it over to the other side. Right, so I'm going to take this x dy dx minus 3y squared dy dx, and then I'll subtract the 2x over, and I'll subtract the y. All right, so we're looking like that. And then the reason I left these on the same side, they're not like terms, I can't combine them, but what I can do is factor out a dy dx, which would be x minus 3y squared equaling this negative 2x minus y. And then I can divide both sides by the x minus 3y squared to get our slope equation. All right, so our slope equation, dy dx, is negative 2x minus y over x minus 3y squared. All right, so now I can use that for anything. Well, they give me a particular coordinate. X is 3, y is 2. I can sub in those values and figure out what is the slope at that particular point. So let me do this. So we're going to do 3, 2. Our slope at that point is negative 2 times our x value of 3 minus our y value of 2 divided by our x value of 3 minus 3 times our y value of 2 squared. So we're getting a negative 6 minus a 2 divided by 3. That's 4 times 3 is minus 12. And so our slope is negative 8. Negative 9 simplifies to 8/9. So there's our slope. Now we can go back over to this and start plugging in our coordinate. So we're finding our tangent line of y minus 2 equals our slope of 8/9. And then x minus our x value of 3. And we'll distribute. We're going to get fractions. So y minus 2 equals 8/9 x minus, and I can put this over 1. You're going to get a 24/9, but I could simplify the 3 with the 9. So that would make it a 1 and a 3. So that would be 8/3. If we weren't quite sure on that, it's 24/9 originally. And then I can take a 3 out of both. So 3, 8. And then I do have a negative on it. And then one last thing is we are going to be adding 2. And I'm going to kind of think I need to make this over 3. I'm already doing the numerator. So 6/3 is what we're going to be adding to a negative 8/3. So our y equals 8/9 x. Negative 8/3 plus 6/3 is going to be a negative 2/3. All right, so let's find out if we're right. So if I take that answer and I'm going to graph, I'm going to plug it into Desmos, and we're going to have y equals 8/9 x minus 2/3. And if we look at that, that looks like it passes through it perfect, and it definitely looks tangent to it. And that's what we were looking to do. So quick summary was we're doing the same thing that we did in the past. We needed to find the slope. So we needed to do the derivative to find the slope equation, plug in your x and y now because your slope equation is a little more complicated than it was in the past. Find your slope, go back to kind of an algebra 1 problem where we're finding the linear equation. And that's it.